Introduction to chemical reactions and balancing equations. A chemical equation is a shorthand for expressing chemical changes. So if we write out a word equation, you can see the reactants are water. If we apply electrical energy, it produces hydrogen and oxygen. So in a chemical equation, we always put the reactants on the left side, the products on the right side, and then there's an arrow that indicates that a reaction is happening. On top or around that arrow, we sometimes put symbols or words to indicate what we have to put into the reaction to make it happen. So in this case, it was electrical energy. In some cases, certain catalysts, and catalysts are substances that are designed to speed up the rate of the reaction. Sometimes it's heat, and sometimes it's other substances. So we can see here in this chemical equation the different components. Now if we draw out the molecular structure, we can see two molecules of water. When we apply electrical energy, it produces two molecules of hydrogen and a molecule of oxygen gas. If we write out symbol formulas, 2H2O, apply that electrical energy, we end up with 2H2 plus O2. Now we haven't seen these large numbers before, so the large number in front of it means that that's how many molecules of that substance we have. So we know that H2O is water. We know that there's two hydrogen and one oxygen in one molecule. But when we put the number 2 in front of it, we're talking about 2 molecules of H2O. So since we have 2 molecules of H2O, we essentially have 2 H2s and 2 O's. So on the other side of the equation, you can see we have 2 H2s and 2 O's. So this is just setting the stage for balancing those chemical equations. Here's another chemical equation. So again, the reactants are what we start with, and we write the reactants on the left side. And then we put an arrow, and this time there's a little triangle over that arrow. The triangle means that heat was applied. Then we produce products. The products are written on the right-hand side, and that's what we end with after the reaction is complete. So copper plus oxygen yields copper 2 oxide. This arrow is called yields. So you notice I said that in the equation. So yields, instead of saying equal to, because it's not a math problem, we say, copper plus oxygen yields or produces copper 2 oxide. Here's a chemical shorthand for a chemical reaction. 4Al, 3O2 yields 2Al2O3. Now the little S's and G's that are indicated here indicate solids and gases. So that's the phase of the matter. So here you can see the S means that this is solid aluminum. We're combining solid aluminum with gaseous oxygen, or oxygen gas. And it produces a solid substance of aluminum oxide. Whole number coefficients indicate the numbers of each substance participating in the reaction. There are special conditions for the reaction that are written over the arrow. So again, as I mentioned, that triangle means that heat was supplied to the reaction. Physical states of each substance are indicated. Again, S and G is referring to solid and gas. And then there's some more symbols that can be found in a chemical equation. So plus means that it's added to, and that's placed between substances. That arrow, as I mentioned, means yields. S is for solid, L is for liquid, G is for gas. AQ is an aqueous solution. An aqueous solution means that the substance has been dissolved in water. And then the triangle, again, that means that heat has been added. So, in this reaction, which one of these is true? This is true. So BaSO4 and CuBr2 are the products. So these two are reactants and these two are products. So how many oxygen atoms are on each side of the equation? So on the left side of the equation, we have 2 oxygen atoms. On the right side of the equation, we have 3 oxygen atoms. In order to balance a chemical equation, we have to have the same number of each type of atom on both sides of the arrow. Atoms can't appear or disappear in the chemical equation, so we must account for the atoms on both sides. So if we look at hydrogen, on this side we have 4 hydrogen, on this side we have 2 hydrogen, so that's a problem. To correct this, we need to create a balanced equation. So a balloon filled with a hydrogen and oxygen gas explodes when heated. The product is water vapor. First, we want to identify the reaction. Hydrogen gas and oxygen gas gives us water gas. Then we're going to write the unbalanced equation. How did I know to put H2? Well, H2 is one of those diatomic molecules. So remember when we talked about some molecules or some atoms naturally exist in pairs? H2 is one of them. Coincidentally, O2 is also one of them. So we wrote H2O2 yields H2O. Now we have to balance the equation. So we have 2 hydrogen on the left side, and there's 2 hydrogen on the right side. There's 2 oxygen on the left side, but there's only 1 oxygen on the left side. So here you can see for hydrogen, there's 2 and 2, but for oxygen, there's 2 and 1. So now we need to balance this. And how we balance it is by putting the number 2 in front of here. So when we put the number 2 in front, that means we have 2 water molecules. In other words, we have 2 of the H2s. So now we have 4 hydrogen on the right side, and we have 2 oxygens. So going back to the beginning, we have 2 hydrogens on the left side, but now we have 4 hydrogens on the left side. In order to balance this one out, we have to put a number 2 over here. So let's start over. We have 4 hydrogen, 4 hydrogen. We have 2 oxygen, we have 2 oxygen, and now this one is balanced. Sometimes we make a mistake and we go back and forth and back and forth and back and forth, and we keep adding and adding and adding and adding more and more coefficients. We always want to reduce this down to the least common denominator. So if we have a 2, a 1, and a 2, we can't divide all 3 of those by the same number to get anything smaller. Because if we divide 1 by anything, it's going to give us a decimal or a fraction, and we don't want to do that. So this is the lowest combination. Phosphorus burns in air to produce diphosphorus pentoxide. So phosphorus plus oxygen yields diphosphorus pentoxide. How did we know to write P4? Well, P4 is how phosphorus naturally exists, so it's not diatomic. It actually exists in attached to 4 phosphorus. That is not something that you will have to have memorized for this class. If there's something like that, I will definitely provide that to you. What you should know is the diatomic ones, because those ones were presented multiple times in the course. So we have P4 plus O2 yields P2O5. So now we want to balance the equation. So looking at this one, we have 4 phosphorus but we only have 2 phosphorus on this side. We have 2 oxygen on this side, and we have 5 oxygen on this side. So, if we start with phosphorus, to get to 4 oxygen on both sides, we're just going to add the 2 coefficient here, because now we have 4 phosphorus, and now 2 times 2 gives us 4 phosphorus over here. But when we go back to looking at the oxygen, now we have 2 times 5, that gives us 10 oxygen. So how do we make this 10 oxygen? We put a 5 in front of it. When you're done with all of your balancing, you always want to go back and double check that it's balanced, and then you want to confirm that it's the lowest possible combination. So this one has imaginary 1 in front of it, so we can't reduce these any further. So this is the lowest possible combination. So now we're going to go back through and just ensure that it's balanced. There's 4 phosphorus, 4 phosphorus, 10 oxygen, 10 oxygen. So that 2 times the 5 gives us 10 oxygen. So now this is a balanced equation. So this is a common question that you may see on your exam. So when properly balanced, the sum of the balancing coefficients is. So let's start by balancing this. So I like to go just left to right. So we have 1, 2, 3, 4 hydrogen on the left side of the equation. On the right side of the equation, we have 4 hydrogen. We have 1 chlorine on the left side, and there's 1 chlorine on the right side. We have 1 nitrogen on the left side, and there's 1 nitrogen on the right side. So this is balanced. So although we typically don't write the coefficients of 1, if they're asking for the sum, we have 1 of these, 1 of these, and 1 of these. 1 plus 1 plus 1 gives us 3. So the sum of the balancing coefficients is asking us to add the numbers that we added in front in order to balance it. So here's another example. Given the unbalanced equation, when properly balanced, the sum of the balancing coefficients is. So now we're going to go balance this one. So on the left side, we have 1 nitrogen. On the right side, we have 2 nitrogen. So in order to balance this, we're going to put a number 2 in front. On the left side, we have 2 times 3, which gives us 6 hydrogen. On the right side, we only have 2 hydrogen. So in order to balance this, we're going to write the number 3 in front of here. Now this one is just assumed to be 1. So recheck. We have 2 nitrogen, we have 2 nitrogen, we have 6 hydrogen, 6 hydrogen. So this is now balanced. Now it wants the sum of the balancing coefficients. We take 2 plus 3 plus 1, and that gives us 6. Zinc metal reacts with silver nitrate to produce zinc nitrate and silver metal. First, we're going to write the unbalanced equation. Then we're going to balance the equation. So on the left side, we have 1 zinc. On the right side, we have 1 zinc. On the left side, we have 1 silver. On the right side, we have 1 silver. On the left side, we need to recognize that there is a family here. And we don't split apart families. So if you remember in previous lectures, I was talking about polyatomic ions. And those polyatomic ions are family groups that stay together no matter what. They have a charge on them, and when we flip up charges or flip down charges in order to do our naming that we talked about, we said that we do not break apart that family group. So anytime you identify an element or a compound, that has more than 2 elements in it, you want to see if there is a polyatomic ion in there, and always put parentheses around it. Now, the parentheses are not necessary to be chemically correct. However, if you put them around there, it will help you visually to understand that that's a family and you don't break that apart. So when balancing, we balance it as a group, not as individual atoms within that compound. So we have one nitrate family, and we have two nitrate families over here. So we're going to have to put a 2 over here to balance the nitrate families. So now we have two nitrate families on each side. But since we added the nitrate family, the number 2 in front of that, we're now going to also have to balance that silver, because silver was part of it. So we're going to have to put a number 2 in front of the silver. So now that one is fully balanced. There's one zinc, 2 silver, 2 nitrates, 2 nitrates. So given this unbalanced equation, when properly balanced, the sum of the balancing coefficients is. So let's go ahead and identify our family group. So this is sulfate. So when balancing, we never want to separate that. On the left side, we have 1 cobalt. On the right side, we have 2. So we're going to put a number 2 in front of here so that that balances. On the left side, we have 1 copper. On the right side, we have 1 copper. So copper seems okay so far. On the left side, we have 1 sulfate family. On the right side, we have 3 sulfate families. So we have to balance this by putting a number 3 here. So now we messed up copper because the 3 applies to copper too. So if we go back and we put a 3 here, it should be balanced. We can't reduce these anymore. So let's go ahead and check. We have 2 cobalt, 3 copper, 3 copper, 3 sulfate families, 3 sulfate families. This is automatically 1. So when we sum the balancing coefficients, we have 2 plus 3 plus 1 plus 3, and that gives us 9. So here's another example. Here on the left side, we have 1 aluminum. On the right side, we have 2 aluminum. So in order to balance this, we have to put a number 2 in front of the aluminum. Now we have hydroxide. And hydroxide, although it is a family, if the family doesn't stay together on both sides of the equation, we can't count it as a family group. So we have OH here, but we don't have OH on the right-hand side. So it breaks apart the family on the right-hand side. So because of that, we have to now balance each one of these individually. I have identified a sulfate group. This is a family group. So let's skip the oxygens and hydrogens momentarily, and let's balance these family groups. So over on the left side, I have 1 sulfate family, and on the right side, I have 3 sulfate families. So if I want to balance the sulfate families, I have to put a number 3 over on the left side. Now that I've done that, I have 2 aluminum, 3 sulfate. Now I have to figure out how to balance this guy. So let's figure out how many hydrogens we have first. So I have 3 times 2 is 6 hydrogen, plus 3 times 2 is 6 hydrogen. That gives me 12 hydrogen. Remember, we're taking all of the hydrogen on the left side, not just the hydrogen from one of these or the other. So all in all, in total, I have 2 times 3 gives us 6, 2 times 3 gives us 6, 12 hydrogen. On this side, I only have 2 hydrogen. So in order to balance this one, I have to write a number 6 here. Now let's look at the oxygen. I have 3 times 2 oxygen gives me 6 oxygen. I am not touching this oxygen. The reason why I'm not touching this one is, remember, this is a family and we don't break apart families. So we have 6 oxygen on this side, and now we have 6 oxygen on this side. So this is finally balanced. We are going to put our coefficient of 1 there just so we can add them up correctly, even though it's not necessary in chemistry. We're still going to write it down. So to add these up, we have 2 plus 3 plus 1 plus 6, and that's 12. Ethylene plus oxygen yields carbon dioxide and water. So first we're going to write the unbalanced equation, and then we're going to balance the equation. So it's a good practice to balance the hydrogen and oxygen last. So I start with the carbon. So I have 2 carbon on this side, I only have 1 on this side. So I have to put a number 2 here. Then we switch to the hydrogen, so I have 4 hydrogen on this side, and I only have 2 hydrogen over here. So in order to get to 4, I have to put the number 2 there. Now we're looking at the oxygen. So for oxygen, I have 2 oxygen on this side, but I have 2 times 2 is 4, plus 2 gives me 6 oxygen. So if you don't know how I got to 6, this oxygen here has the effect of this 2 and this 2. So 2 times 2 is 4, so that's 4 oxygen with this one. And then this 2 carries over to the oxygen over here, so that's another 2 oxygen. 4 oxygen plus 2 oxygen gives me 6 oxygen. So to balance out the oxygen on this side, I would have to do 3, because 3 times 2 is 6. So let's go back through and see if this is balanced. I have 2 carbon, 2 carbon. 4 hydrogen, 2 times 2 gives me 4 hydrogen. I have 2 times 3, which gives me 6 oxygen. I have 2 times 2, which gives me 4, plus 2 gives me 6 oxygen. So now this one is balanced. Acetylene plus oxygen yields carbon dioxide and water. So first we write the unbalanced equation, and then we're going to balance the equation. So starting with the carbon, we have 2 carbon over here and only 1 over here. So we're going to add the 2 coefficient. Then we switch to hydrogen. We have 2 hydrogen and 2 hydrogen. So hydrogen appears to be balanced. Now we're going to switch to oxygen. We have 2 oxygen over here, and we have 2 times 2 gives us 4, plus 1 gives us 5 oxygen over here. That's an odd number. So how do we go about balancing when there's an odd number? We're going to use the fraction method. In the fraction method, you're going to use the number of oxygen over here divided by the number of oxygen over here. So the fraction you're going to put in front of this oxygen is going to be 5 divided by 2. Where did this 5 come from? Well, that's the number of oxygen that are on the right side of the equation. And the 2 came from the number of oxygen on this side of the equation. The problem is we can't leave it like this because this looks really messy. So we're going to have to multiply away this 2 on the bottom. So if we multiply the whole equation by 2, we end up with 2C2H2 plus 5O2 yields 4CO2 plus 2H2O. How did we get that? We just carried in the 2. So 2 was carried into this one. 2 times 5 divided by 2 just gives us 5. 2 times 2 gives us 4. And 2 times 1 gives us 2. Now we do want to go back and make sure this is balanced still. 2 times 2 is 4. So we have 4 carbon on this side, we have 4 carbon on that side. 2 times 2 is 4, so we have 4 hydrogen on this side. We have 2 times 2 gives us 4 hydrogen on this side. Over here, we have 5 times 2, which gives us 10 oxygen. Here, we have 4 times 2, which gives us 8 oxygen, plus the 2 oxygen here, and that gives us 10 oxygen. So given the unbalanced equation, how would we balance this? Okay, let's start with the carbon. So there's 2 carbon on the left side, and there's only 1 carbon on the right side. So in order to balance out the carbon, we're going to put a 2 here. There's 6 hydrogen on the left side, and there's 2 hydrogen on the right side. So to balance this one, we're going to put a number 3. There's 2 oxygen on the left side, and there's 2 times 2 gives us 4, plus 3 oxygen gives us 7. So there's 7 oxygen on the right side. 7 is an odd number. So in order to balance out these oxygens, we're going to have to use that fraction method. We're going to write the number of oxygen on the right side divided by the number of oxygen on the left side. And then we're going to multiply away that denominator. So we're going to multiply the entire equation by 2. So that gives us 2C2H6 plus 2 times 7 divided by 2 is just 7O2, plus 2 times 2 gives us 4CO2, plus 2 times 3 gives us 6H2O. When we add all of these together, we get the balancing coefficients summed to 19. Another example. So given the unbalanced equation, when properly balanced, what is the sum of the balancing coefficient? So we have 3 carbon here and only 1 over here. So we're going to have to put a number 3 here. We have 8 hydrogen over there and 2 hydrogen over here. So in order to get to 8, we're going to have to put a number 4 there, because 4 times 2 is 8. We have 2 oxygen over here, and we have 3 times 2 gives us 6, plus 4 gives us 10. So we are going to have 5 oxygen over here. 5 times 2 gives us that 10. So now we can see we have 3 carbon, 8 hydrogen, 4 times 2 gives us 8 hydrogen, 5 times 2 gives us 10 oxygen, 3 times 2 gives us 6 plus 4 oxygen gives us 10 oxygen. Adding those up, we get 13. Remember, this is like automatically assumed to be 1.